So all of this work we have been doing with the factoring is to lead up to solving of polynomials. Okay. What does it mean to solve a polynomial?
X equals whatever.
Yeah, find the zeros, right? X equals whatever when what? When y is equal to 0, okay? Which is also called the x-intercepts. Bless you.
Thank you.
Okay, so when we are given a polynomial, like in the first one where we have f of x equal to 3x times x plus 5 times 4x minus 1 times x minus 7, and they're told, we're told to find the zeros, right? So again, what happens when you set the whole equation equal to 0? What is nice about this one? It's already factored, right? So at this point, all I have to do is look at each of the pieces, the components that went into it, and we apply the zero product property, right? So in the beginning, I have 3x. Do I have to take that 3x into consideration?
Yes.
No.
It's going to be 0.
Okay.
What is it?
It's going to be 0, but do we have to take it into account? Why?
It could be, the x could be 0.
Okay, because the x is on it. Okay, if it were just 3, would we have to do anything with it?
No.
No, but the x on there tells us we do have to apply that one. So our very first one is 3x equals 0, which means this x would be 0. Right. Our next one is x plus 5 equals 0. So this x is negative 5. Our next one is 4x minus 1 equals 0. So this x is 1/4. And our last one is x minus 7 equals 0. So this x is equal to 7. So how many zeros did we end up with? 4. All right, and I'm just going to list them in order. X equals negative 5, 0, 1/4, 7. And those are our zeros.
How much in terms of like work do you need to see for this?
I do not need to see this step over here. I don't need to see you write out the individual ones either.
Okay.
Yeah, it's perfectly fine just to write down the x equals.
This is too simple. I don't trust it.
It's because we're easing you in.
We've had like 20 minutes of class.
Okay. So for our next one, f of x equals x cubed minus 2x squared minus 9x plus 18. And again, if we want to find the zeros, that means I have to set the entire equation equal to 0. And what changed in this one?
It's not factored.
It's not factored, so we're going to have to factor it. Any thoughts on what method we should use?
The two parentheses, because there's 4 variables.
It's called factor by grouping. Yeah, I see 4 terms. That's usually the first thing I try. All right, so I'm going to group these two together. And let's see, I'm going to turn that into a plus, group these, and put a negative on my 9. Okay, so in my first group, what's that?
Oh, never mind.
Oh, yeah, because it started out with a minus 9.
Oh.
Yeah. Yeah. Okay, so in my first group, what can we factor out of there? X squared. So I get x squared there, and that leaves me with an x minus 2. And what can we factor out of our next group? Actually, we're going to do a negative 9 so that we get an x minus 2 again.
Is it okay if you change the signs on like the tail end? Like if you don't like put it at the beginning?
Okay, if you keep that minus on the outside, what it means is you have to flip the sign of the next term. Yeah, you can do that at the beginning too. Okay, what would be our next step?
Switch it around.
Rewrite it with the new set of pairs, but that's also
Okay.
the difference of perfect squares.
Beautiful.
So then you
That's what I was hoping you would recognize. All right. So those are the two factor pairs now, but x squared minus 9, as Landry said, is a difference of two squares. What does that factor into?
x plus 3, x minus 3.
There we go. And carry down the x minus 2. All right. What are my zeros?
3, negative 3, and 2.
3, negative 3, and 2, and I'm just going to write them in order.
Can we write plus or minus 3 for x's on this, or do you want us to write all 3 out?
No, I'm fine with plus or minus.
Okay.
Okay. All right. So is this really anything different from what we've been doing? No. The only thing is we've gone one step further and found what x is equal to. Okay. So on our next example, it says what happens when you have repeated solutions. So when you read this equation, we have 5 times x minus 2 times x plus 3 squared times 2x minus 1. What do you think they mean by repeated solutions?
Multiple things, multiple of the x's are the same, so like there could be like 2x where it equals 3.
Okay. What do you notice in this equation?
There's 2x plus 3.
Okay. So yes, x plus 3 occurs 2 times. All right?
Oh, because it's squared.
Yes.
Wait, so what is just the x?
Okay. So again, if we're finding the zeros, we're still setting it up equal to 0. It's already factored for us. Do I have to do anything with that 5?
No.
No, there's no x on it, so we don't have to do anything with that. And can we already see, what is our first 0 going to be? 2. And I'm going to skip this one for a sec, and I'm going to take the last one. 2x minus 1 would give us a 0 of 1/2. And now I'm going to address this last one. What is the 0 for that? Negative 3, except how many times did that negative 3 occur? Twice. So I'm going to, nope, not negative 6, but what I'm going to do is follow it up with multiplicity of 2, because there were 2 of them. Are we okay over there?
Yeah. It got like really simple and then all of a sudden.
No, it's still simple.
It's just funny.
It just
because,
sounds-
like, it sounds hard.
But is it?
We just put negative 3, and then like that was just it at my old school. We didn't put multiplicity. Yeah, it's interesting.
Yes, right.
What happens with 5?
Well, the 5 doesn't have a variable attached to it, so it would be like if you divided it out, you'd have 0 divided by 5.
Okay.
So just the 0. Okay. So what would happen if, let's say, this were x plus 3 to the 3rd power?
Multiplicity of 3.
Multiplicity of 3. X plus 3 to the 4th power? Multiplicity of 4. Exactly. Okay. All right. Let's look at our next one. I have g of x equals 5x cubed minus 40x squared plus 80x. All right, again, I want to find the zeros. What are your thoughts on what we should do first?
Factor out
Just x?
5x.
5x. All right, so we're going to factor out 5x to start. That leaves us with x squared minus 8x plus 16. That's all equal to 0. All right. 5x doesn't factor out anymore, but what about that trinomial there? X minus 4. And what? And x minus 4. So there's actually 2 of them, x minus 4 squared. All right. What's my first 0? 0. What's my next 0? 4. But I have to follow that up with a multiplicity of 2. kind of a fun word to say, isn't it?
Can we put mult P? Mult is just kind of long.
It is kind of long. Yes, I'm fine with mult. Yes.
1 factor right 16.
What do you mean
Instead
16?
of 4 plus 2.
Because the 0 is not 16. The 0 is 4. It's happening 2 times.
Okay.
Yeah.
So like
Uh-huh.
if it was on a graph, it would like
I'm glad you asked, because that's what we're going to look at next.
Oh, no, thank
Okay.
you. No, thank you.
All right. I printed these out for you. The 4 that I gave you, one of the factors, it's because those are not so straightforward in factoring, and I didn't want you to have to spend so much time figuring those out. Those factors are not typed on the paper, so you'll have to refer to the screen for these. So work with your table mates, factor these polynomials out, and then match the polynomial to the graph.
Is there a point in a year where we won't have to like have graphs?
No.
I was just hoping.
Wait,
Because like I can do the math and then like you put a graph in
there's
there.
graphs in calculus?
Oh, yes.
That's all it is. There's like circle graphs. Wait, what about geometry?
Well, no, that's more shapes.
Yeah, but you could have a shape on a graph.
Yeah, well, you can actually on a coordinate set.
Yeah.
Yeah.
Coordinate. Why do you know my
On a coordinate plane, I should say.
Geometry is my least favorite.
Okay, so let's look at. Uh-oh, why won't it let me move? There it goes. Okay, the graph of big A goes with what?
C.
Little c. The graph of big B goes with.
E.
The graph of big C goes with. Little b. Graph of big D goes with.
A.
Little a. The graph of big E goes with. Little d. And the graph of big F goes with. Okay. All right. So what I want you to look at now is, well, let's talk about E and F first. The graphs of E and F first. What was going on with those two graphs?
They had 2x.
2 x-intercepts?
I mean, one was.
Oh, 3.
3. 3 distinct x-intercepts, right? So this one had an x minus, sorry, that would have been an x plus 2, would have had an x, and it would have had an x minus 1. 3 distinct x-intercepts, all right? And F, we had one at 0, one at 1, so that would have been minus 1, and one at 2. So again, 3 distinct x-intercepts. All right, I'm going to jump up to A and B next. How many x-intercepts did they each have? They had 2. Okay, so let's look. This one here would have come from the expression of x plus 2. And this one here came from what? X minus 1. But how many times did that x minus 1 occur? Twice. Okay. All right. Let's look at big B. We have an x-intercept here. That would have come from x minus 2. And how about this x-intercept here? What did that come from? X plus 1. How many times did that occur? Twice. Okay. Look at the difference between the intercept of 2 versus the intercept of negative 1 and what it was factored from. And also in A, the difference between the intercept of negative 2 and positive 1 and where it came from. What do you notice?
Oh, the last sign of the original thingamadoodle was just flipped, so instead of minus 2 for C, it's plus 2. For the original thing, the original numbers. That we
Okay,
got.
so there were a difference in signs. What else do you notice about the behavior of the graph?
The
Right, so again,
vertical shift down whatever
Okay.
number.
so again, let's look at A. We have this intercept here, which came from x plus 2, and we have this intercept here that came from x minus 2. What do you notice about that graph? What is it doing at the x-intercept?
Changing direction.
Well, not direction, but it's changing from a negative to a positive, okay? Versus what's happening this one here. There's a multiplicity of 2 on that positive 1, and there's a multiplicity of 2 on this negative 1. How does the graph differ from the points that don't have multiplicities?
There's like a line, or like a stay. Not like a stay, but like it's. You know, I don't know what the word for it is. I know what it is, but like
Parabola?
it
Is it a
stays on.
Well, they're not parabolas. It's like
Yeah, like a but it's. You can see it's like. I know what
Okay.
I'm thinking, but I don't know how to say it in words.
Okay, well, let's look. This one here, what are we doing?
We're going up.
Okay, and we're going through versus what's happening here.
Going down.
Are we going through?
Parabola.
So it's not that it's parallel, but what are we going through it? We're just bouncing back. Same here. What's happening with this one? Bouncing back. There's a multiplicity there, and this one here doesn't have a multiplicity, and it is going through. Do you guys see that? Do you see it? At the multiplicity of 2, it bounces back, right? Okay. So slightly different in the cube. Was it difficult to match these graphs once you had the factorization down? No, there was only one x-intercept in each of these. So we knew that this one had to have come from the one that had the x minus 1. And we knew that this one had to have come from the one that had the x plus 2 in it. Okay. We haven't really talked about the details of cubics yet. We'll do that not next class. So next class we're looking at function operations, and we have our quiz. Don't forget we have a quiz. The class after the quiz, we are going to be going into graphing. And so this is sort of an intro into that.
And so this is not on our quiz.
The graphs are not on the quiz, but the factoring is, finding the zeros is.
Solving,
The quiz is on Friday.
wait, solving polynomials.
Y'all's quiz is Friday.
Okay, so then okay.
Okay.
Because then we have a class in between it, right? It's Wednesday.
Yeah, we have class Wednesday.
All right.
Yes, and the material on Wednesday won't be on the quiz. Okay. I think probably a lot of you are not, so we'll get you rescheduled. Okay, so again, I just wanted you to guys be familiar with the fact of, again, what is it when we're finding a zero? It's just the
Intercepts.
x-intercepts, okay?
We could
So
plug the thing into like our calculator and get the graph thingy and do the intercept. And like not like
if
on
it's
the
a
test or
if it's a
something,
calculator
but
problem,
like we could. That's
Yeah.
like a way to find it.
yeah, and there's a specific function operation in your calculator for the zeros specifically. Okay, but again, kind of want you to just make sure you understand that the x-intercepts are the zeros. Okay, they're going to show up on the graph, and just to sort of start to familiarize yourself with what it looks like when you have a multiplicity versus not having a multiplicity. Okay, so we have a couple more examples we want to go into. So this first one, well, these are all about finding the equations of the polynomials, just depending on what kind of information we're given. So in the first couple here, it's asking us to write the equation of the polynomial function of least degree that has a leading coefficient of 1 and the given zeros. Okay, so when it says, you know what, and I'm going to add on here, put equation in standard form. Okay. All right. So again, we have to come up with the equation. When it says it's the least degree, that means we're just going to look at the zeros. How many zeros do we see?
3.
We see 3. Are there any multiplicities on any of them? No. So by saying least degree, we know that we're going to have a third degree polynomial.
How do we know it's the least degree?
Because you have 3 zeros. And there's no multiplicity. So you're not going to have any extras anywhere that are being hidden.
Would still be to a third degree because there's a multiplicity.
Yes.
Too?
Yes. Okay. So it has to indicate. And again, the leading coefficient is 1. Okay. All right. So we've done problems very similar to this already. We've done it with our quadratic equations and we've done it with our absolute value equations. And so now we're just adding on higher degree polynomials. All right, so I'm going to start with f of x is equal to, if the leading coefficient is 1, that means I'm just going to put a 1 in here. Now I'm going to work backwards and look at my zeros. If I have a 0 of 3, what expression would that have come from?
X minus 3.
X minus 3. Okay. If I have a 0 of negative 4, what expression would that come from? And my 0 of 1 would have come from the expression x minus 1. All right. So right there, this is a correct solution, except that I added that part on there to put the equation in standard form, which means, what do we have to do? We have to multiply, yes. Undo the factorization, multiply everything out.
Cancel out that 1.
Don't have to worry about the 1. I'm just going to start with the first 2 here. X minus 3 times x plus 4. So that gives us an x squared plus a 4x minus 3x minus 12. And all of that will be multiplied by x minus 1. I'm going to go ahead and combine my like terms before I do that next part. So x squared plus x minus 12 all times x minus 1. And then we'll multiply those together. So I have an x cubed minus x squared plus x squared minus x minus 12x plus 12. And again, collect our like terms. X cubed is by itself. And I love, love, love when this happens. What happens with that negative x squared plus x squared? Yes. Love getting zeros. Okay. Negative 1x minus 12x minus 13x plus 12. And there is our polynomial function of least degree with the leading coefficient of 1.
What does least degree mean?
So we started with 3 zeros, and so that means we're only going to have a third degree polynomial. There's nothing hidden. Yeah, there's no hidden x's in there that we were supposed to find.
Are we going to have hidden x's?
No. Yeah.
What's the meaning of third degree?
There's 3 x's, right? So it's a third degree. So if you only have 2 x's, it's a second degree. All right. For our next one, we have zeros of 0 and 2, but 2 has a multiplicity of 2. Okay. But again, this is part of the same example. We still have a lead coefficient of 1. I'm going to just name this one g of x since we just used f of x. Okay. So how do I represent my 0 of 0? What expression would that have come from? Just an x. Okay.
That would also make our leading coefficient 1 too.
Yes. I'll write in leading coefficient of 1. Okay. And then my 2, what expression would 2 have come from?
X minus 2.
X minus 2, but because it's a multiplicity of 2, I have to square it.
And should we put this in standard form?
Yes, and we're going to go ahead and put this in standard form. So I'm going to, which part should we do first? The exponent, which is only on this parentheses here. So I'll hold x out here. And because it is a square, it has that pattern of x squared minus 2 times this, each of these terms. So 2 times x times negative 2. So that's minus 4x plus 4. And the last thing is to distribute that last x through. So we get g of x equals x cubed minus 4x squared plus 4x. And there is the polynomial that has the 3 zeros of 0, 2, which happened twice, and a leading coefficient of 1. All right, so what do we think of those?
It's just undoing the problem. It's like unraveling it.
Okay. But difficult? All right. Okay. We're going to change things up just a little bit with the next one. So now we're going to write the equation of the polynomial function with the given zeros and a y-intercept of 5. All right. So, what does that mean? Y-intercept of 5. Yes, Ava?
When you put it in standard form, 5 has to be C for the last term.
Okay. And so what coordinate does that represent?
Whatever x is 0.
When x is 0, y is 5. Okay, so that's what I want to point out here. All right, and so now I'm going to start building my polynomial here. So I have f of x is equal to, it did not tell us what the leading coefficient is this time, so we don't choose it. We're going to put a in, just like we did when we were working with the quadratics and our absolute value functions. All right, so now I want to build this. I had a 0 of 5. What expression did that come from?
X minus 5.
X minus 5. Okay. I have a term of a 0 of negative 3. That expression would have been,
X plus 3.
and our last one, my 0 of 1, the expression would be
X minus 1.
x minus 1. Okay. So I have built this. The only thing I don't know yet is the a term, or the leading coefficient. So now that's where that y-intercept comes into play, because I'm going to plug it in, right? So y is equal to 5 when x is equal to what? 0. So now I'm just going to plug in 0 minus 5, 0 plus 3, 0 minus 1. So I get 5 is equal to a times, that's negative 5 times positive 3 times negative 1. So 5 is equal to 15a. All right, which means what is a equal to?
3.
Other direction.
Oh, what?
1/3.
Oh.
Remember, we're isolating the a. And then the only thing left is to plug that a equals 1/3 in. So I would have f of x is equal to 1/3 times x minus 5 times x plus 3 times x minus 1. It did not ask us to put it in standard form. So do I want to put it in standard form?
No.
No.
Too much more work.
Yes, it's a lot more work.
We're lazy.
We're not lazy. We are efficient.
Ah. Speak for yourself. I am lazy.
There's a difference.
Expert.
Okay.
Stab my hand.
All right. Yes.
Sorry. How would you put it in standard form? What's the standard form again?
You would have to multiply everything out. So just like we did up here, like this up here is standard form.
Okay.
Yeah. And we don't want to do that in this one. Okay. Last example. Write the equation of the polynomial function. We have zeros of -2, 4, a multiplicity of 2, and goes through the point 2, 8. Okay. So just like we did earlier, I'm going to build this. I'm going to go ahead and use g of x again, just because. Okay, I don't know what the leading coefficient is, so I'm going to put it in a. And now I have to build my expressions here. If my 0 is -2, that came from the expression of x plus 2. Okay. And if I have a 0 of 4, that expression would be x minus 4. But because there's a multiplicity of 2,
Square.
I need to make sure I square that.
Do we just leave it like that, or do we have to do stuff with the x minus 4?
We have to find a.
Well, I know we have to get the a and stuff like that. But, like, am I asking, before we put in the point 2, 8, do we have to do more stuff?
No, leave it like this. Much easier like this. All right. So, y is equal to 8 when x is equal to what value? 2. So I'm just going to plug in 2 plus 2 here, and this is 2 minus 4 here. All right. So that means 8 is equal to a times 4 times, and then if I have 2 minus 4, that's -2. -2 squared is +4. So that means that 8 is equal to 16a, which means a is equal to 1/2. All right, and the only thing left is to put it all back in together. So g of x is equal to 1/2 times x plus 2 times x minus 4 squared.
My brain hurts.
Your brain hurts? Were these that bad?
This is the lesson that I've understood.
Okay. So, is it all starting to come together?
That makes me. I like.
Is there a quiz extra practice?
Yep, already posted.
Alright, so start.
Okay.